Hello students, let me welcome you all to my 7th video on the chapter solutions, right? In the 6th video, we discussed something about the ideal solutions, properties of ideal solutions, and of course examples for the ideal solutions, right? In the today's video, we'll go for the one more kind of solutions, that is what we call it as non-ideal solutions, right? Non-ideal solutions. And what we said, this classification of solutions into ideal and non-ideal solutions will be based on whether the solution follows Raoult's law or not. If the solution follows Raoult's law over the entire range of concentration and temperatures, and that is called as ideal solutions. If the solution does not follow Raoult's law over the entire range of concentration and temperature, and that is called as non-ideal solutions, right? And of course, in the case of ideal solutions, what we said, delta H of mixing is equal to 0, delta V of mixing is equal to 0, right? Delta H of mixing is equal to 0 and delta V of mixing is equal to 0. At the same time, in the case of ideal solutions, and that is the AA or BB interactions among the molecules of pure components will be equal to the AB interactions among the molecules of the solution, and that is the main property of the ideal solution. Because of that, delta H of mixing is equal to 0, delta V of mixing is equal to 0, and thereby they follow Raoult's law of, yes, it is the liquid solutions. And of course, in the case of ideal solutions, that is the total vapor pressure of the solution is equal to, yes, the total vapor pressure of the solution is equal to the vapor pressure of the solution as we predicted by Raoult's law. The total vapor pressure of the solution as we predicted by Raoult's law. This is the total vapor pressure of solution predicted by, yes, it is Raoult's law, and this is total vapor pressure of solution calculated from the experiments. If both are same, and then that solution is called as, yes, it is ideal solutions, right? Whereas in the case of non-ideal solutions, that is the total vapor pressure of solution is not equal to the vapor pressure of solution as we calculated by, yes, it is Raoult's law. So this is the nature of, yes, it is non-ideal solutions. Or you can say in the case of non-ideal solutions, that is PA is not equal to, yes, it is XA into P naught A, right? Or you can say PB is not equal to XB into P naught B, right? This is what we call it as non-ideal solutions. If I say total vapor pressure of solution is not equal to the vapor pressure of solution as we predicted by Raoult's law, if it is so, there are two possibilities. That is, the total vapor pressure of solution may be greater than, yes, it is PA plus PB. This is one possibility. Another possibility is total vapor pressure of solution may be less than PA plus PB. If I say total vapor pressure of solution is not equal to PA plus PB ಅಂತ ನಾನು ಹೇಳಿದ್ರೆ ಎರಡು possibility. It may be greater than PA plus PB or it may be less than PA plus PB. Accordingly, non-ideal solutions are of different types. Accordingly, non-ideal solutions are of two types. So one, it will be non-ideal solutions showing positive deviation. Another is non-ideal solution showing negative deviation. Look at this. Yeah, that is P total greater than PA plus P. That is non-ideal solution. Non-ideal solutions showing positive deviation. Okay. It is showing positive deviation where experimentally determined vapor pressure of solution is greater than that we calculated by Raoult's law. And in the same manner, the second type is called as non-ideal solution showing negative deviation. Non-ideal solution showing negative deviation. That is, the total vapor pressure of solution is less than that we calculated by, yes, it is Raoult's law. So this is what we call it as non-ideal solutions. And of course, in the case of non-ideal solutions, A to A interactions or B to B interactions are not equal to AB interactions. So these are the interactions among the molecules of pure components in solution. This is interactions among the molecules of solution there. Yes, it is. This is interaction between A and B in the solution. If these two interactions are different, and that solution is called as, yes, it is non-ideal solution. Is it not? So we'll see that what is that differences between non-ideal solutions with positive deviation and non-ideal solutions with negative deviation. We'll see one by one. Yes. For the first one, that is non-ideal solutions with positive deviation. That is non-ideal solutions with positive deviation. Positive deviation. Yes, it is that in the case of non-ideal solutions with positive deviation, the total vapor pressure of solution is greater than the vapor pressure of solution as we calculated by Raoult's law. So this is the nature of, yes, it is the non-ideal solution with positive deviation. That means the vapor pressure of solution increases on mixing two liquids A and B. So total vapor pressure of solution increases on mixing liquids A and B. That's why it is called as positive deviation. And in the case of non-ideal solutions with positive deviation, that is delta H of mixing is greater than 0. That is also positive. And at the same time, delta V of mixing is also greater than 0. Okay, now these are the properties of non-ideal solutions with positive deviation. Now I have to give the reason why delta H of mixing is positive. That is when two liquids are mixed, heat will be absorbed. That is endothermic process. Heat is absorbed here. Heat is absorbed. That's why it is delta H of mixing is greater than 0. Here, when two solutions are mixed, the total volume of solution decreases. For example, if I take a liquid A and B equally, right? If I take 10 ml of A and 10 ml of B equally, yes, the total volume of liquids will be 20 ml before mixing. After mixing, if the volume of solution becomes 20.2 ml or 20.1 ml anta itkoli, 20 agbekiತ್ತು 20.2 no 20.3 no 20.4 agide. That means what? Total volume of solution increases. Therefore, delta V of mixing is greater than 0 in the case of non-ideal solutions with positive deviation. In the case of non-ideal solutions with positive deviation. Yes. And the question lies here is why that is delta V of mixing is greater than 0. Delta V of mixing is greater than 0. Why? Total vapor pressure of solution increases when two liquids are mixed. Okay, now consider liquid A where we have, yes, it is AA interactions. So the pure liquid AA interactions is there. Just consider one more liquid. Yes, it is B where we have, yes, it is BB interactions are there. When these two are mixed, you are going to get solution with AB interactions, right? And this is solution, right? This is pure components. These two are pure components, right? In the case of non-ideal solutions with positive deviations, right? A to B interactions among the molecules of solution. Yes, A to B interactions among the molecules of solution will be less than A to A or B to B interactions. That is, interactions among the molecules of solutions decreases when two liquids are mixed. That is, A to B interactions are, that is, intermolecular force of attractions among the molecules of A and B will be decreased when these two liquids are mixed. And when intermolecular force of attractions are decreased, if intermolecular force of attractions among the molecules of A and B decreases, vapor pressure increases. Vapor pressure increases. Now, imagine a liquid. Yes, it is. Here we have A and B interactions equally. And above the surface is characterized by vapors. This will exert what? Vapor pressure. Just nobody. If AB interactions are weak, if force of attraction between A and B weak, easily the molecules will escape into the vapor phase. Amount of vapor in the solution increases. Therefore, vapor pressure increases. That is, since A to B interactions among the molecules of solution are weaker than A to A or B to B interactions among the components of pure liquids, that's why vapor pressure of the resulting solution increases. Therefore, they show positive deviation from Raoult's law. They show positive deviation from Raoult's law, right? And of course, yes. And for the same reason, because of that, yes, because of that, in the case of solutions with positive deviation, delta H of mixing is positive. Heat is absorbed. As A to B interactions are weak, A to B interactions weak, the amount of heat liberated is less. Therefore, in order to break, yes, it is the force of attractions among A or BB. In order to break force of attractions among A to A or B to B molecules, heat will be absorbed from the surroundings. Amount of heat liberated in this case is less. Therefore, in order to break the force of attractions among A to A or B to B molecules, heat will be absorbed from the surroundings and thereby solution results. Because of that, delta H of mixing is 0. And for the same reason, delta V of mixing is positive. Yakendre A to B interactions are weak. Force of attractions between A and B weak iddage enagutte? They maintain larger distances. Houdalva? A to B madhya force of attractions weak iddage enagutte? The distance between two molecules will be more. Again enagutte? Volume expands. That's why delta V of mixing is positive. And of course, as far as okay na, so this is, and of course examples for that would be, yes, it is to consider acetone plus ethanol. Mixture of acetone and ethanol will form, yes, it is positive deviations from, yes, it is they will show positive deviation from Raoult's law. Why it is so? In the case of ethanol molecules, the C2H5OH, there are, yes, it is hydrogen bonding among the molecules of, yes, it is hydrogen bonding among the molecules of ethyl alcohol. Howda? Acetone, in the case of acetone, there are dipole-dipole attractions. In the case of acetone, there are dipole-dipole attractions. Howda? Yes, this is dipole-dipole attractions in the case of acetone. Acetone alli dipole-dipole attractions irtade. Ethyl alcohol alli hydrogen bonding irtade. Howda? Yes. When acetone is added to ethyl alcohol, acetone molecules are going to break the hydrogen bonds. Acetone molecules are going to break the hydrogen bond between the ethyl alcohol molecules. If the hydrogen bond has broken, force of attraction decreases. Therefore, the force of attraction between ethyl alcohol molecules and acetone molecules, right? Ethyl alcohol molecules and acetone molecules will be less here due to the breaking of hydrogen bonds among the molecules of ethyl alcohol. Therefore, if the interactions between ethyl alcohol molecules and acetone molecules will be very, very weak, and therefore they show what we call it as positive deviation from Raoult's law. They will show positive deviation from Raoult's law. In the same manner, example, why acetone and ethanol will show positive deviation andre acetone molecules are going to break hydrogen bonds of ethyl alcohol, and therefore the force of attractions among the molecules of ethyl alcohol and acetone decreases, and thereby they will show, yes, it is positive deviation. Adike na helite AB interactions are weaker than AA or BB interactions. Second example is, that is mixture of acetone and carbon disulfide. Mixture of acetone and carbon disulfide, that also shows what we call it as positive deviation, because upon mixing, yes, it is these two liquids, the force of attraction between acetone and carbon disulfide will be very, very weak. This is A to A interactions andre, idu B to B interactions anta itkondre idenagutte A to B interactions. So the A to B interactions in, yes, it is in the case of acetone and carbon disulfide will be less than those in the case of AA or BB interactions, and because of that, that will show what we call it as positive deviation. Yes? Right? Now at this moment, I'll go for the non-ideal solution showing negative deviation now. Yes? Non-ideal solution showing negative deviation, that is. Non-ideal solution showing negative deviation. In the case of non-ideal solution showing negative deviation, look here, that is the total vapor pressure of solution is less than the vapor pressure of solution as we predicted by Raoult's law. The total vapor pressure of solution is less than as we predicted by Raoult's law. Athwa experimentally determined vapor pressure of solution is less than that we predicted by Raoult's law. So in that case, solution is said to be showing negative deviation from Raoult's law. The solution is said to be showing negative deviation from Raoult's law. In such solutions, PA will be less than XA into, yes, it is P0A, and PB is less than, yes, it is XB into P0B. This is what we call the nature of the non-ideal solution with negative deviation. Similarly, that is delta H of mixing is negative there. Delta V of mixing is also negative there. This is what we call it as yes, it is non-ideal solutions with negative deviation. Now so the reason now, what is the reason why the total vapor pressure of solution, yes, it is decreases, because in these cases, look at this, A to A interactions, B to B interactions among the pure components. When these two are mixed, you are going to get A to B interactions. In the case of non-ideal solutions with negative deviations, A to B interactions are stronger than A to A, or B to B interactions. A to B interactions are stronger than A to A or B to B interactions. That force of attractions among the molecules of solutions will be very, very strong. If the force of attraction is strong, more and more heat will be liberated. If force of attraction is strong, more and more heat will be liberated. Therefore, delta H of mixing is negative. That is exothermic. If more and more heat is liberated, part of the energy liberated is used to break AB or AA or BB interactions. Remaining will be given out in the form of heat. Therefore, exothermic, delta H is negative. A to B interactions are strong. Molecules are coming closer and closer. If molecules are coming closer and closer, volume of solution decreases. Therefore, if I take 10 ml of A, 10 ml of B, result just maybe 19.8 ml or 19.9 ml. Okay, na? Total estitu 20 mix madidmele estayitu 19.8 yake AB interactions are strong. Mix madidmele A matte B molecules ಗಳ ಮಧ್ಯೆ interaction strong ಇರೋದ್ರಿಂದ molecules are coming closer and closer. ಏನಾಗುತ್ತೆ? Total volume decreases. That's why the delta V of mixing is negative. That's why delta V of mixing is negative. Yes. And just imagine, look at this. In a solution, look at this. If AB interactions are strong, if AB interactions are strong, the vapors above the surface of solution will be less. AB interaction strong, less number of molecules will be escaped into the vapor phase. Weak idre, more number of molecules will be escaped into the vapor phase. AB interaction strong, amount of vapor on the surface of liquid is less. Therefore, vapor pressure is less. Therefore, total vapor pressure is less than that we calculate by, yes, it is Raoult's law. And of course, as far as vapor pressure of solution is concerned, vapor pressure of solution can be related to the boiling point also. Because boiling point is the temperature at which vapor pressure of solution is equal to the atmospheric pressure. If the vapor pressure of solution is more, boiling point is less. Vapor pressure is inversely proportional to boiling point. If vapor pressure of solution is more, boiling point will be less. If vapor pressure of solution is less, boiling point will be more. Okay, na? In the case of non-ideal solutions with negative deviation, yes, total vapor pressure of solution decreases. Boiling point increases. Boiling point of solution increases. And that's why non-ideal solutions with negative deviation will form, yes, it is high boiling azeotrophs. Non-ideal solutions will form azeotrophs. Non-ideal solutions will negative deviation will form high boiling azeotrophs. Non-ideal solution with positive deviation only vapor pressure ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಆಗ boiling point ಕಡಿಮೆ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ non-ideal solutions with positive deviations will form minimum boiling azeotrophs. Minimum boiling azeotrophs. Minimum boiling azeotrophs. ಇಲ್ಲಿ maximum boiling azeotrophs. ಇಲ್ಲಿ negative deviation ಅಲ್ಲಿ maximum boiling azeotrophs. Positive deviation ಅಲ್ಲಿ minimum boiling azeotrophs. ಯಾಕಂದ್ರೆ positive deviation ಅಲ್ಲಿ vapor pressure ಜಾಸ್ತಿ ಆಗುತ್ತೆ, boiling point ಕಡಿಮೆ ಆಗುತ್ತೆ. ಇಲ್ಲಿ vapor pressure ಕಡಿಮೆ ಆಗುತ್ತೆ, boiling point ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಇಲ್ಲಿ vapor pressure ಜಾಸ್ತಿ ಆಗುತ್ತೆ, boiling point ಕಡಿಮೆ ಆಗುತ್ತೆ. ಹೌದು ತಾನೆ? Here vapor pressure decreases, boiling point increases. And of course, boiling point is inversely proportional to vapor pressure. So this is what we call it as non-ideal solutions with negative deviation. If you want to represent that particular aspect, graphically, I'll give the graph now. Yes. Raoult's law graph for the, yes, it is non-ideal solutions with negative deviation, right? So this is the graph. This is vapor pressure along x-axis. This is mole fraction, right? Here it is xp is equal to 0, xa is equal to 1. Here xp is equal to 1, xa is equal to 0. Howda? Yes. Okay na? Hagagi ಏನಾಯ್ತು ನೋಡಿ ಈಗ. And this is, and of course I said this is a graph for P total, right? Total vapor pressure of solution, right? And here it is xb 0 ಇರೋದ್ರಿಂದ along x axis xp value ಜಾಸ್ತಿ ಆಗಿದೆ. This is for pb, right? ಹೌದಾ? Here ಈ ಡೈರೆಕ್ಷನ್ ಇಂದ ಏನಾಗುತ್ತೆ, xa value ಜಾಸ್ತಿ ಆಗುತ್ತೆ. That is, this is for pa, right? This is for pa, right? Okay na? And this is for ideal solutions, right? And if there is a negative deviation, ಏನಾಗುತ್ತೆ ನೋಡಿ, ಇದು Raoult's law ಪ್ರಕಾರ straight line. Negative deviation ಅಂದ್ರೆ ಕಡಿಮೆ ಆಗೋದು, that is decreases. ಇದು Raoult's law ಪ್ರಕಾರ, ಹೌದಾ? Negative deviation ಅಂದ್ರೆ decrease ಆಗೋದು ಈ ತರ, right? ಇದು negative deviation ಅಂದ್ರೆ decrease ಆಗೋದು ಈ ತರ. This is what we call it as, yes it is graphical representation for, yes it is graphical representation of Raoult's law for, yes it is solution showing negative deviation. ಹೌದಾ? Okay na? In the case of solution showing positive deviation ನೋಡಿ, in the case of solution showing positive deviation ನೋಡಿ, right? In the case of solution showing positive deviation, right? Yes, this is vapor pressure. Look here, this is 0. Here x2 is xb is equal to 0, xa is equal to 1. ಹೌದಾ? Here it is xb is equal to 1, xa is equal to 0. ಹೌದಾ? Then this is, and for the Raoult's law, this is P total, right? This is P total, right? xp to x1 ಅಂದ್ರೆ this is for, yes it is pb. ಹೌದಾ? ಈ ಕಡೆಯಿಂದ ಬನ್ನಿ, xa 0 ಇದೆ, ಇಲ್ಲಿ ಬಂದ್ರೆ this is for, yes it is pa. This is for pa, right? Positive deviation ಅಂದ್ರೆ ಏನು, ಜಾಸ್ತಿ ಆಗೋದು. So this is positive deviation. ಇದು Raoult's law. Positive deviation ಅಂದ್ರೆ ಏನು, ಜಾಸ್ತಿ ಆಗೋದು ಈ ತರ, right? ಇದು Raoult's law. Positive deviation, this is positive deviation, right? So this is a graph for, and of course mole fraction, right? This is a graph for, yes it is a non-ideal solution showing positive deviation. This is for positive deviation. It will be negative deviation. Is that clear? Yes. ಹೌದಾ? Okay na? ಅದೇ ideal solutions ಆದ್ರೆ, yes it is ideal solutions ಆದ್ರೆ, this is vapor pressure versus mole fraction, right? ಹೌದಾ? So this is for P total there. Okay na? Right? Yes. This is 0, xb is equal to 0, xa is equal to 1. Here xb is equal to 1, xa is equal to 0. ನಾನು ಹೇಳಿದ್ದೀನಿ ನನ್ನ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ, some of the mole fractions of all the component in the solution is, yes it is 1 ಅಂತ ಹೇಳಿ. This is for b, this is for pb, and this is for pa, right? Okay na? So this is, okay na? This is for ideal solution. This is non-ideal solution with negative deviation. This is non-ideal solution with positive deviation. ಅರ್ಥ ಆಯ್ತಾ? So this is what we call it as, and of course as far as examples for the non-ideal solutions with negative deviation are concerned, examples for the non-ideal solutions with negative deviation are concerned, we have, yes it is phenol and aniline, the mixture of phenol and aniline. I am talking about examples for non-ideal solution with negative deviation. Phenol, you know, phenol is characterized by hydrogen bonding, yes, and this is what we call it as delta plus and delta minus, and here it is a hydrogen bonding is there among the molecules of phenol. In the case of aniline, yes, you know, aniline is also characterized by, yes it is nitrogen atom with lone pair of electrons. ಹೌದಾ? Nitrogen atom with lone pair of electrons. ಹೌದಾನೆ? Because of that, when phenol and aniline are mixed, ಏನಾಗುತ್ತೆ, there is a strong force of attraction among the polar OH group of the phenol and the nitrogen containing lone pair of electrons of the aniline. And because of that strong force of attraction, ಏನಾಗುತ್ತೆ, the solutions will show negative deviations. ಅಂದ್ರೆ, if I say this is A, if I say this is B, AB interactions are very, very strong, and therefore they show negative deviation due to the polar OH bond and lone pair of electrons over the nitrogen. In between them, you know, ಏನಾಗುತ್ತೆ, that is strong force of attraction will be established. Therefore it will show, yes it is negative deviation. ಹಾಗೇನೆ, you take acetone, right? This is acetone, yes, double bond more, right? Oh, you know, this is delta minus and this is delta plus. This will form hydrogen bond with, yes it is the chloroform, that is chloroform, and this is delta plus because of high electronegativity of chlorine atoms. The CH bond is very polar, highly polar. Therefore, positive end of the chloroform attracts the negative end of, yes, it is acetone, and that results in intermolecular hydrogen bonding. You know, the force of attraction is very strong due to the intermolecular hydrogen bonding. Here in the case of acetone, you have dipole-dipole attractions. In the case of chloroform, you have dipole-dipole attractions. So when both are mixed, hydrogen bonding establishes, and that is stronger than dipole-dipole and dipole-dipole attractions. Therefore, here also A to B interactions are stronger than A to A or B to B interactions, and because of that, yes, it is acetone and chloroform will form non-ideal solution with negative deviation. Yes, so that is what we call it as ideal and non-ideal solutions, and of course differences among the ideal and non-ideal solutions. Artha aitu ankotini, right? Agboda? Thank you. Now at this moment, we'll take up one more topic that is related to this particular ideal and non-ideal solutions, that is azeotropic mixtures, or you can say that azeotropes. And generally, azeotropes or azeotropic mixtures are the constant boiling mixtures. We call them as the mixture of two liquids which will boil at constant temperature without undergoing any change in composition. That is what we call it as constant boiling mixture athwa azeotropic mixture. That is mixture of two liquids which will boil at constant temperature without undergoing any change in composition. That is called as non-ideal solutions. Sorry, azeotropic mixtures athwa azeotropes athwa constant boiling mixtures. Okay na? ಏನಪ್ಪ ಈ ಅಜಿಯೋಟ್ರಾಪ್ಸ್ ಇವುಗಳಿಗೆ ಯಾಕೆ ಅಷ್ಟು ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡ್ತೀವಿ ನಾವು ಅಂತಂದ್ರೆ ಇದ್ರ ಬಗ್ಗೆ ಸ್ವಲ್ಪ ನಾನು ಮಾತಾಡ್ತೀನಿ. ಜನರಲಿ ಅಜಿಯೋಟ್ರಾಪಿಕ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಆರ್ ಫಾರ್ಮ್ಡ್ ಬೈ ಓನ್ಲಿ non-ideal solutions. Such type of solutions will be produced by only non-ideal solutions. Okay na? Ideal solutions do not form azeotropic mixtures. One example ಕೊಡ್ತೀನಿ, right? Just imagine that is ethanol prepared from, yes, it is fermentation of molasses. It is generally 10% ethanol. And then artha 90% water irutte anta artha. Okay, 10% ethanol andre ಏನು ಅರ್ಥ? ಇದರಲ್ಲಿ 10% ethanol idre 90% water irutte anta artha. This is the ethyl alcohol obtained from anaerobic fermentation of, yes, it is molasses. If I subject it for the distillation, right? If I subject it for the distillation anta itkoli athwa distillation madidre ಏನಾಗುತ್ತೆ? Now you are going to get mixture of ethanol and water. Mixture of ethanol and water, that is with say for example percentage of ethanol increases. ಏನಾಗುತ್ತೆ? Percentage of ethanol ಜಾಸ್ತಿ ಆಗುತ್ತೆ. If I subject it for the distillation, ಅಂದ್ರೆ distillation ಅಂದ್ರೆ ಏನು? The mixture will be heated to its boiling point. ಹೌದಾ? Vapors are collected and condensed back. Okay? Why the percentage of ethyl alcohol is increased? Because out of ethyl alcohol and water which is having low boiling point, ethyl alcohol has got low boiling point. Again, more and more vapors of ethyl alcohol will be formed, and of course percentage of ethanol increases. Because of low boiling point of ethanol, it readily vaporizes compared to that of water. Hage distillation continue madidre enagutte? Percentage of ethanol increases 60% agutte. Continue ಮಾಡಿ ಹಾಗೇನೆ, and it will increase 90% ಆಗುತ್ತೆ, right? Percentage of ethanol ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, and it will reaches the value that is 94.5%. Say for example that is around 95.5% ವರೆಗೆ ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. 10% ಇಂದ ಏನಾಗುತ್ತೆ? The percentage of ethyl alcohol goes on increasing. So in all the steps, we followed distillation ಅಥವಾ fractional distillation. Now distillation ಮಾಡ್ತಾ ಇದ್ವಿ, therefore that percentage of ethanol goes on increasing. After reaching this percentage, if I subject it for the distillation further, the percentage of ethyl alcohol remains same, and because ethyl alcohol will form azeotropic mixture with water at this composition. Ethyl alcohol will form azeotropic mixture with water because that is mixture of ethyl alcohol and water will form non-ideal solution. Percentage of, if I subject the distillation further, that is composition of the ethyl alcohol remains same. Adike helid now. Azeotropic mixtures are constant boiling mixtures which boil at constant temperature without changing composition. ಇಲ್ಲಿಂದ ಡಿಸ್ಟಿಲೇಷನ್ ನೀವು ಎಷ್ಟು ಸರಿ ಮಾಡಿದ್ರು ಕೂಡ ಏನಾಗುತ್ತೆ 95.5% ಇರುತ್ತೆ. ಹಾಗೇನೆ 10% ಡೈಲ್ಯೂಟ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ತಗೊಂಡ್ರೆ ಓಕೆನಾ, ದಿಸ್ ಇಸ್ ಡೈಲ್ಯೂಟ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್. 10% ಡೈಲ್ಯೂಟ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ಅಂದ್ರೆ 10% ನೈಟ್ರಿಕ್ ಆಸಿಡ್ 90% ವಾಟರ್ ಇರ್ತದೆ. ಇದು ನಂಗೆ ನೀವು ಡಿಸ್ಟಿಲೇಷನ್ ಮಾಡಿದ್ರೆ 68% ವರೆಗೂ ರೀಚ್ ಆಗುತ್ತೆ. 68% ವರೆಗೂ ರೀಚ್ ಆಗುತ್ತೆ. Once the percentage of nitric acid becomes 68%, you know, it will form azeotropic mixture with water. If I subject it for the distillation further, percentage of nitric acid remains same. That is why nitric acid is said to be forming azeotropic mixture with, yes, it is water. That is what we call it as azeotropic mixtures. The constant boiling mixtures which will boil at constant temperature without changing composition, they are called as azeotropes. Only non-ideal solutions will form azeotropes. Ideal solutions do not form azeotropes. And at the same time, I included one point there. In the case of non-ideal solutions with positive deviation, non-ideal solutions with positive deviation, that is, non-ideal solutions with positive deviation, you know, they form. That is what we call it as minimum boiling azeotropes. Andre ಪಾಸಿಟಿವ್ ಡಿವಿಯೇಷನ್ ಅಂದ್ರೆ ಏನು, ವೇಪರ್ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ವೇಪರ್ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆದ್ರೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ರಿಸಲ್ಟಿಂಗ್ ಸೊಲ್ಯೂಷನ್ ಡಿಕ್ರೀಸಸ್. ಅದಕ್ಕೆ ಮಿನಿಮಮ್ ಬಾಯ್ಲಿಂಗ್ ಮಿಕ್ಸ್ಚರ್ಸ್. ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್ಸ್ ವಿತ್ ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ ಬಂದ್ರೆ ದೇ ಫಾರ್ಮ್ ದಟ್ ಇಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬಾಯ್ಲಿಂಗ್ ಅಜಿಯೋಟ್ರಾಪ್ಸ್. ಯಾಕೆಂದ್ರೆ ನೆಗೆಟಿವ್ ಡಿವಿಯೇಷನ್ ಅಂದ್ರೆ ಏನು, ವೇಪರ್ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಆಗೋದು. ವೇಪರ್ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಆದ್ರೆ ಏನಾಗುತ್ತೆ, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಆದ್ರೆ ದಟ್ ಮೀನ್ಸ್ ದೇ ಫಾರ್ಮ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬಾಯ್ಲಿಂಗ್ ಅಜಿಯೋಟ್ರಾಪ್ಸ್. ಎಲ್ಲಿ, non-ideal solutions with negative deviation. So these are the differences among, yes, it is ideal and non-ideal solutions, and of course non-ideal solutions with positive deviation and negative deviation. So with that information, in the next video we'll go for the very important discussion as far as your syllabus is concerned, that is colligative properties. You know, I know around 4 colligative properties, right? We'll see that.